and today I was going to bring you a very brief and to the point tutorial about working with Web3.js. So Web3.js is obviously a JavaScript library that allows you to interface with a lot of Ethereum and Solana and other blockchain wallets, but doing it through kind of a like normalization layer. So like instead of importing, specifically window.ethereum, which like right now, for example, I have MetaMask installed. If you were to go to window, like any browser with MetaMask installed has window.ethereum available, which allows you to sign in and read the interface with the blockchain in a very simplistic format. Web3.js takes that a step further, and Web3.js allows you to interact with contracts and all of that. And so I really don't have any code written besides this very basic HTML, template, which I just made just purely for the sake of this demo. And we're just going to walk through everything. We're going to consult the documentation probably several times. I'll probably have to Google some very simple Stack Overflow questions because I just don't use the space in my brain to memorize stuff that I can just Google. So we're just going to get into it. And I already kind of templated what we're going to be doing. So the first thing is log in and save the Ethereum address. So by save, we're going to store it in the browser's local cache. You could save it to a database and extend upon this further. But all we're going to do is save it locally because I had made a video in the past and some people had talked about, hey, how do you save this data? I don't want to have them log in every single time. And that's totally fair. So I'm just going to show people how to do that with local store. It's pretty simple. And, let's just get started. So this is the code. Hopefully it's visible. This is a pretty basic HTML website. I'm using Tailwind for the style. So all this class stuff you don't need to see. This entire file, by the time we're done, by the time you watch this video, it'll be available in the description as a GitHub gist that you can just download. So we have, 3 buttons? So we have a button here for the login and save Ethereum address. We have a log out button that is hidden because we don't want to show that unless we have an address saved, because otherwise, what's the point? And then we have a button for getting contract info, which we'll get into this. This will be a whole thing in and of itself. So first, let's just try to see if we can figure out how to log in, right? Because that's the first problem. So logging in with Web3.js actually invokes JavaScript promises. So this is something that you're going to need to use the async await keyboard. So async and await keywords. So async basically is what you would declare for a function. So for example, we're going to have an async function and it'll be called login with ETH, right? And we don't need any parameters because there's nothing to do. It's hey, we're logging in, just pop open the browser and let's get this done. So this is an async function. Anytime we need to call another asynchronous function, but we don't want to just continue with the rest of the code, we can use await. But before we can even do any of that, let me just refer back to the head here. We have a link for the Tailwind CSS sheet, but we also have this script tag. This imports Web3.js. This is what we're going to be using to do all of the fancy stuff here. So the first thing that we need to do is check if the person has Ethereum installed, it has MetaMask installed in their browser. If they don't, then let's just do an else statement and alert them no ETH browser extension detected. And honestly, if we went to reload the page, which by the way, I'm running this on localhost 8000. If you were running this under file : / index.html, this whole process will not work for you. All of these browser wallets only work if you are on a server, even if it's local. They have to be on some kind of server instance. Easiest way to do that is actually Python 3-m- http.server. If you have Python 3 installed, which on your Mac you automatically do, then you should just run this in the folder of index.html and it'll start up a localhost server for you. It's probably the simplest way to start a server. So localhost.8000, we have MetaMask installed, so this alert is not going to pop off. But if we just go to incognito, we shouldn't have one installed unless I actually have it ported over, which I very well might. Let's see. Is window Ethereum undefined? It is. Oh, I'm done. We haven't even invoked the function. So let's have it to where when you click the button, let's have the onClick function do login with ETH. Now, if we reload this, no ETH browser extension detected. Now, in this browser, which we're going to have to reload, we don't have dynamic reloading, so every time we make a change, we'll have to refresh. But with this button, if we click it, we shouldn't get the alert, and nothing happens. So what we're going to need to do now is do two things. First, we're going to have to establish a Web3 kind of instance, which I've already kind of done here, where we're going to make a window Web3 instance. And we're pretty much going to take the Ethereum object that already exists and pass that into Web3. And what this does is initializes a window Web3 environment variable that is a Web3 instance that we want to connect to Ethereum. So this right here will be very useful. In fact, it actually may even be something that we want to abstract out to later. But we can, deal with that when we want. So the next step, which actually I have all this stuff kind of written here, is this try catch statement. So the first thing we need to do is enable Ethereum, which basically says like, okay, Web3, we said we wanted to talk to Ethereum, and now we're going to start. And the first thing we want to do is get a list of accounts. And so the way you do that, this is an asynchronous process. So we're going to await Web3 talking to ETH, get accounts. This will pop open MetaMask and should pop open any other Ethereum-based wallet browser, depending on what's installed on the user's browser. This should give us an array of wallet addresses. So let's go to debugger. And also if the user, for whatever reason on this get account pop-up, if they just say like, oh, I didn't want to log in, and they click reject, that will throw this error. But let's just see what happens first. So we'll refresh. We'll click log in and save with ETH. And you can see this is all on Rinkeby. This is not my actual ETH balance. That would be amazing. And I probably wouldn't be making YouTube tutorials. And so anyway, we see we got a list of accounts here, and I only selected one to be done. So we actually only have this first address, which this is, a real Ethereum address. And since we only want the first one, we could just do, account, and it would be just the, 0th object of accounts. Now, this is also important. How do we save this item to the browser's local storage? Well, I kind of just gave it away on that one. And it's actually, you can access local storage from the browser, and you can then do set item. And this is where we assign it a key. So we'll call it user address, or do user maybe ETH address maybe? User address is probably fine. We're only working with Ethereum here. And the value that we want to store is actually this guy. So once we have this stored, there's some things that we're going to want to be preserving here, right? So for example, when the script first boots up, when this whole page loads, we kind of want to have this window Web3 object always available, because we're probably going to use it in other places. And also, we want to make sure that, we want to enable Ethereum from the get-go as well. So what we should probably do is probably have like a window onload kind of function that as soon as the page has loaded, we're going to want to kind of run this script, but without the login portion. So essentially, we want to just delete these two things. And I guess we can catch this. And yeah, we can have this. Okay, so basically what we're going to do is when the window loads, we're going to check the window object to see if it has Ethereum. If it does, we're going to set a window Web3 variable equal to the, telling Web3 that we're going to be connecting to Ethereum, and then enable that process so that every time now that we call window Web3, we can just kind of go straight to Web3 ETH get accounts. So actually in this whole process, we can simplify it by essentially, instead of checking for window.ethereum, we can check if window Web3 exists. And then from there, Ethereum should already be enabled. We should be able to just kind of, bypass all of this. And if window Web3 has not been established yet because this function is not run, we should get the alert. And so let's just see if this works. We'll throw a debugger in here and let's comment this out because I don't quite want to store something yet. Let's refresh and see if, again, we have a asynchronous function. So we actually need to define this as async. And wait, window.onload is not a function. Hold on. Here we go again. Window onload. Look at that. I probably Google it so much. Window onload. I guess we could just do this one. There we go. We could probably just do that. This is... Okay. And let's see if this gives us some errors now. Okay, so we should be good. And let's check if window Web3 exists, and it does because we're in the console now. And so if I click this button, we should get the debugger, and let's see if we get accounts. And we do get that array that is one item long, which it contains the address that we've already approved. Now keep in mind, once I've authorized access in my MetaMask wallet, let's see if we scroll this, hit connected sites, scroll down, you'll see localhost 8000 is already a connected site. If I trash it, it's going to prompt us again the next time we click this button. So, I have to reload the screen. My bad. Let's go to connected site. Let's see if it wound up back. We're on localhost 8000, not 3000. Yeah, so now MetaMask is going to ask us to log in pretty much straight once we load the page because we haven't authenticated the site and we're kind of asking to interface with it. So we'll click connect. And then if we click login and save ETH address, we'll be able to get the account. And now let's go store the item that we've got into the user local store, which is going to be under the key user address. So now when someone loads this page, there's two things we can do. We probably want to have a window user address variable, and we can just make it null at first. And then also have at the bottom of this script, so this is kind of initialize Web3 connected to ETH, right? Initialize Web3 connected to ETH. There's another thing that we want to do in here, and that's also load in the local storage item if we have it. So the first thing we can do is, let's see, load in local store key. So the first thing is we'll have to do window, let's see, local storage, and we want to get item user address. Now, what we need to be careful about is we need to make sure that this variable exists, because otherwise we're just going to wind up with nothing. And basically what I'm planning on doing is if a local store available item exists, then we're going to set it, but we're also going to fill out this little paragraph tag we have here called user address and unhide the logout button so that when you click logout, it does something, which will basically be deleting the item from the local storage. So when you log in using blockchain connected wallets, it's not the same as logging in with Google. You don't get an auth token per se. Basically, all you get is access to that user's wallet address. And then also you can then begin to prompt them to do other actions like interface with the contract, et cetera, et cetera. We don't really need to do anything too advanced in this example, but if you had a database, for example, instead of using you could identify unique users instead of by email or by some auth token or anything like that, you could just do it by their wallet address because no one has the same wallet address. So it's just another way. You have to think about login a little bit differently than how you would with Web 2. Again, this is a very basic example. This also breezes over a lot of technical aspects and system architecture and other things that you would maybe consider in a larger scale app. This is more just how do we use Web3, because Web3 is really powerful, this Web3.js library. So let's see what happens if we try to reload the page and access this item, which may or may not be empty. So user address, as you can see, is going to be null. It's actually the same variable as up here. So actually we can just do this because these guys are named the same. So this window variable by the same name would have scope in this function. So let's reload the page again. So what is window? It's null, which is what we initialized it as. But if we go to continue, and now if we click login, we should execute this local storage function. So we'll click login and save, which it just happened. I clicked the button and it just happened. And we didn't notice because it didn't prompt us to log in because I already have this site authenticated. The way that you can check that is if you go to application and then go to local storage and click on the site, you'll see that we've got some other BS in here, but we have user address, right? Look at that. Like we have user address already stored in there. So that's awesome because that means it exists. And also if you want to delete keys, you would just go here and you could just go to delete key and now it's gone. And if we refresh the page, user address will still be empty. And now we can click login and save again, and it will be saved. It's already there. If we want to check, we'll go back to application and user address is there. And now next time we reload, when the window onload function loads, we have a value because we have stored it. And then when the window onload function fired again, we gained it. So what we want to do now is probably have a generic function that we can run both at the end of window onload and after you click a button. And what that's going to do is put the address here and unhide the logout button. So let's just make a generic function like that. Let's just call it a function show address. And it's going to take in a variable called address. That will be a string or null actually. And what we want to have here is basically if no address, then we want to return false. Because pretty much if we call this function and there's no address because it's null because the user has never authenticated before or anything like that, just at this point, just get rid of it. Like it doesn't even matter. Like just don't even bother doing what we're about to do. But what we want to do is we want to actually grab this variable, right? Which is going to be, so we could do document get element by ID and then just set text. I guess we could just set text equal to address. Actually, we could even get fancy and do a string template and do like eth address and then pass in address. Okay, and so that should do that. And then the next thing we want to do is unhide the hidden function from logout button. So we'll do document get element by ID, logout button, class list, remove hidden. Okay, and so now we have this function and we want to run it right after we store the item because we know we'll have an address, right? Which is going to be this one. And this is setting the item. We probably also want to set window.userAddress here to the 0th account as well, because obviously we want that to be accessible as this window object, which honestly, because we're setting it as a window object, we don't even need to pass anything here because essentially it's going to get set on load from this value, and then we're going to call show address. And then right here, we set it again, and then we can call, and then we would call show address, which honestly at this point we don't even need. So what we can do here is just do window user address. And basically if window user address has not been set, then nothing is going to happen. This function will just return early. And this is an asynchronous function. So let's refresh. And since we have a key stored, we should automatically see this stuff. And so you'll see we have a logout button. It doesn't look like our text came through though. Oh, maybe it's because this has to be inner text. Yeah, there we go. Okay, so you'll see that we actually set this string eth address, right? Because we're logged in and we make the logout button available. Okay, well, what do we do about the logout button? Well, that's actually quite easy because all we really are worried about is clearing out this user address and clearing out our storage item. There's actually two easy functions for that. So we'll do logout and that doesn't really need anything. And so the first thing that we want to do is window user address and set it back to null. It should be empty because that's kind of the way that we initialize it. And then the next thing we want to do is remove the item under the same key in our local storage. So we would do window.local storage, and we would do, I think it's remove item, and this is where you would specify the same exact key. There we go. And then what we want to do is just to, for extra measure, what we would actually like to do is probably, instead of returning false early, we'd probably just like to make sure that our text remains empty. And that also, that this class list, we add back hidden. And the reason for that is that if, for example, we are toggling this show address, then if there's nothing there, we want to make sure that we set the user address if something was there, such as in the fact of where we're logging out. I want to clear out this string and then hide the logout button. And then otherwise, if I do have an address, then we're going to, set the string and remove the button. So let's just make sure that that works. But first we have to wire up this logout function. So let's just go up to our logout button. Again, we'll have another onClick function, log out, and let's reload the page and click log out, and something broke or nothing happened. So let's see. Oh, actually, this show address will never be null. So this will never, so all this did is just run this function again. So I'm wondering if, well, because this should run, oh, we never called it. Look at that. There we go. Okay. Reload. And then because I clicked log out, it did wind up removing the storage key. It just didn't wind up refreshing the UI like it was supposed to. So let's click log in and click log out. Click log in, click log out. And all we're doing is we're asking Web3, give me the address that is authenticated for this app, and then we're going to display it on the front end and show this logout button. And then the logout button deletes the item from the browser's local storage, so we don't know what it is the next time we reload, and also sets the address that we think we know back to null. There we go. And so that is logging in and logging out and persisting the data across multiple refreshes because we're using the browser's local store. So there you go. That's like a very easy way. You can click this button as many times as you want. It's not gonna, it'll just keep resaving the item. It won't do anything more than that. It'll just keep resaving it to the browser's local storage, and then you just click log out once and it'll be gone. So there you go. So now that we have login and save done, let's log back in, we're going to do this get contract info. Now, this is where the power of Web3.js really becomes unlocked, and also where I'm going to need to consult the documentation. So there are a couple things to know if we go to, for example, this contract, I think. So this is a contract that I have created, I believe. Is this one? Here, let's go to this guy's address. And there should be some contract mints on here. Mint contract. Okay. So this is a contract that I have created with Ramp, okay, which is in a previous video, and I'll probably link it in here. And you can see that this is like, some Solidity code, like it does some stuff, it has to do with NFTs and stuff like that. But that part's not important. What is important is that there is read and write contract values here. So these are all functions, kind of like you would have in JavaScript. It's really kind of the same. So like here's one of like minting. If you're an admin, you just pass in an address and then you can execute this function. We're just going to be reading because that's the easiest thing to do. So like, for example, there's a price value. Like this is the value of what an NFT would cost to mint in a unit called WEI, Way. It's like pretty much Ethereum multiplied by 1 to the 18th power, 10 to the 18th power, or 1 to the 18th power, sorry. But basically it's a number, right? It's a number that means something. Ramp address is a address of a different account that gets paid on this thing. Base token URI. These are all readable variables that we can get and are stored on the blockchain. So what we're going to do is we're going to try and get the name of this contract. Let's just try and get name and maybe if the minting is open status. So the easiest way to do this is we'll have to have an async function. And we'll say get contract details. And of course, we don't really need anything here. There is kind of one overarching thing we will need, and that is the contract address, because how are we supposed to know what we're going to interact with if we don't know what the contract address is? So we'll have a constant here, and we'll call it, contract address. And actually, because this is such a, something we're going to be using multiple times, we can just kind of have it, you know what? No, let's just have it as a constant in here, and we'll just keep it uppercase, even though that's technically not what we should be doing. But what we want to do first is we need to do two things. So we need to interface with kind of Web3's contract library. So Web3 contract, which also I wonder if we'll need the ABI for this, which we probably will, which will get a little complicated. Because as you can see, we have this. So yeah, we'll need the JSON interface and the address. So let's see how we can do this. Because I have all this information already. So window Web3 contract, is contract available? ETH contract. Okay, so contract is available because that's where we're gonna be needing some stuff like this. Because as you can see, if we call contract here, we're going to need to pass it an interface, which a ABI interface is essentially, it's actually right here in the code. It's pretty much one long, which you can get this from any contract that's been verified on Etherscan, just to be clear about that. It's one giant JSON object that pretty much says like, hey, if you're trying to call this function, this is the property for it, right? And it's pretty important that you have this and that you know this, or else there's pretty much like the way Web3.js works is that when you call a function, it needs to know essentially like what are the parameters for that function, what type of what is the actual name, right? Like ramp address right here. What does it output? Where can I find it? Does it take any inputs? This pretty much tells you everything you would need to know about a contract in JSON format, and we're going to need this. So we're actually going to copy all of it because we need it. And this should all be valid JSON. And this is a really big string. So we're going to just make this like window.abi, and we're going to make it just a giant JSON object, which is going to be absolutely massive. And actually, if I close this window, which I don't need this anymore, and then reopen it, it'll format it properly. And actually, if we go into here and debug it, and then wire up our contract info button on click. When we click this get contract info button, we should debug here, but we should also have access to this window ABI button. So let's see if that works. Get contract info, and if we do window.abi, you see we have this giant array of JavaScript objects, which is perfect because that's exactly what we need. Again, if you want to interface with the contract on the blockchain, it needs to be verified, where this contract source code is verified. So you would go and find a contract on the blockchain, like right now we're on Rinkeby, which actually we'll have to specify. Well, actually, if our wallet is connected to Rinkeby, which it is, Web3 should work the same. But you need to know a contract, and this contract of it's very confusing because it says contract twice, but this you need to know the address and also the code for it, which you can find the raw source code for how the program on the blockchain runs, but also the contract ABI, because without this, you can't use Web3.js. It's absolutely imperative that you have this information, which if it's verified, it exists. Okay, moving on. So we have this ABI. The next thing we need to do is go look at this kind of function right here, where basically it says we create a contract object, right? Which we're going to do const. So this contract will be a new, and it's window.web3.eth.contract. And it takes a JSON interface, which is actually this window ABI, and the address is the contract address. And then you can see in this next function, it says contract, which is this variable, methods, which is a property of contract, and then some function and then you would do .send or .call, actually is another one you could do, from, and it could be, just the current address. And then you can see there's like this whole asynchronous kind of callback tree for this. So for this, we'll just delete this, and this will be, so when it says from, it's basically what address is calling this function. So that right there is actually going to be window.user_address, right? Because we already have, excuse me, we already have this logged in. And also the name of our function is actually not nameless. We know what it is. We're going to try and call, what variable should we try to call? I mean, we had said name, but yeah, let's do name. Let's see what name returns. So if we do name, and I believe this should be on receipt. Actually, I think we can just await this. We can just await this. And let's do call. Pretty sure call is the right one. Let's see what happens here. So we're going to refresh, get contract info. Response is everything contract. So there you go. So we got it. So now you can see that actually we have this response object, and where name is pretty much just whatever we're trying to call. If we go to the contract and we were to type in the exact same case, ramp address, right? This would give you this address, which actually we can do that here. We do ramp address. And if we reload the page and click get contract info, we should be able to get that. Ramp address is not a function. Uh-oh. Did I spell it wrong? Oh, I'm pretty sure I spelled it wrong. Yeah, RAMPP. Forgot the name of my own little startup. Wow, that's embarrassing. Anyway, response. You can see that we get the value that the blockchain says stored this value. If I wanted to modify this contract and change this variable to something, instantly, as soon as that transaction was verified, Web3.js would also pick it up when we queried for it again. If we wanted to call minting open, same process, minting open. And if we refresh the page, click get contract info, response is true, which is coincidentally, and actually not a coincidence, this very same response that we get here. So pretty much what we've now done is any contract that is verified on the blockchain. So now any contract that we find on Etherscan that is verified, we can go and visit it. You can go check out the source code if you want to see how to write Solidity code, or if you're interested in a contract. We can copy its ABI, paste it into our program, right? And then just, go to read contract and even write contract. You can actually write. You can actually send values to this. That's a little out of scope, but it works in very much the same way. So for example, right, if I had the permission to with this user address, right, if I wanted to, which actually I believe the owner of this contract is me. Hold on, we might be onto something. Actually, I'm telling you people it's out of scope. It is not out of scope. Owner, where is owner? Owner. Yeah, I'm the owner. Okay, well, if I'm the owner, then let's just see what this looks like for me to call it. So sorry about that. Well, if you made it this far in the video, then I guess you're going to get a treat. Is stop minting, sorry. And this doesn't take any arguments, and we should be able to call it from this address, which hopefully should still be there. So reload. And okay, there we go. So we're just going to call an easy function, and you can see it automatically pop up MetaMask and says, hey, you're about to call the stop minting function. Now, because this address that we've been working on happens to be the owner of this contract, I can execute this and it won't fail. But if I didn't own it, this execution would fail. But we're going to reject it because I actually don't want to close minting on this example contract. But essentially, that is how you would do it. So actually, let's just, it's not even getting contract details, although I guess it kind of is. Let's just go back to getting the name, which when you're sending data, right, you need to use .send. But when you're asking for data, reading, you want to use .call. And then this is the name of the variable, and you would add this little parameter, this little function call behind it in case you need to pass in any variables. Like if we were trying to ask, does a specific address own a token? You would use the address as the argument, and this would be, balance of or whatever. But let's see, what else can we grab? There's so much information we can get. Let's go to read contract, and let's do the symbol, which for this should be like ERAMP or something like that, which actually, you know what, before we even check, yeah, it's ERAMP. So click this and we do response and we get ERAMP. So there you go. So that is how actually, we got a little bonus in there, but this is a very, very basic example of how you would use Web3 to log in, persist that user's login upon refresh. Now, of course, it's only limited to our browser. If you wanted to use a database, you would have to extend upon this further. And also a way to not only fetch details from a contract, but also possibly even mutate values on a contract, depending on if you have the permissions to do so. And all you need is a validated contract on Ethereum. You can just go find one. Doesn't even have to be yours. As long as it's validated, you can read from it. You may not be able to write to it, but you can read from it at least. And if you want to use this contract, by all means, go ahead. It'll be already in the code, and the ABI will already be there. I'll probably clean this up a little bit, add some comments, so you don't have to watch the video every single time you look at the script. But this should just give you the very, very first stepping stone into how would you kind of interact with the blockchain, and maybe in the future even build a decentralized app. So that's it.